Okay, I am going to go over some problems from the review. Sorry I cannot be there today. Please make sure that you turn in your my.hrw.com assignments 12.2 and 12.3, and make sure that you prepare for the test on Thursday. Make sure that you can do each type of problem from the review, and that should be a good indication of whether or not you are prepared for the test or not. So again, I'm going to go through some problems from the review to help you prepare. Okay. So this first question here, okay, or these first 5 problems anyway, here are about simplifying expressions with exponents. Okay. So for example, this problem number 1, when we have a exponent outside the parentheses, what we need to do is we need to make sure that we distribute it to each of the terms inside of the parentheses. Okay? So therefore, this would be 5 to the third a. Now then, when you're distributing a power into a parentheses, you want to make sure that you are multiplying it by the exponents that are already inside the parentheses. Okay, this is called power of a power rule, and in that case, you multiply powers. So 2 times 3 is 6, so that's going to give me an a to the 6th and b to the 3rd. Well, 5 to the 3rd is 5 times 5 times 5, and that is going to be equal to 125. Okay, and that would be the simplified answer there. Okay. Now then on number 2, sorry about that. I just had to make sure that it was still recording. On number 2, negative 3x to the 0 power. Well, anything to the 0 power is equal to 1, so that's just going to be equal to 1. Remember that we don't want to have answers that have negative exponents in it. Okay, so on a problem like number 3, what we want to do, now the 4 doesn't have a negative exponent, so we don't want to drop it down to the denominator, but we do want to take this x to the negative 2 and drop it in the denominator, and actually in doing that, that will change that exponent from negative to positive. Okay? And then on number 3, this is another problem where you can see that we want to distribute the exponent into the parentheses. Okay? So we got y to the 1/3, k to the 4/5 raised to the 3rd power. So I just want to distribute that 3, multiply it by the 1/3, and also multiply it by the 4/5. Again, power of a power rule. You want to multiply those powers together. So 3 times 1/3 would be 1. So that would be y to the 1 power. And 4/5 times 3 is going to give us a k raised to, now 4/5 times 3, that's going to be actually 12 over 5 as the exponent there. All right. And then number 6. Okay, so there we want to multiply. We're going to go ahead and multiply in the numerator, and then we will divide. Okay, so I want to multiply the 2 terms in the numerator and then divide. Okay. So that's going to be 2 times 5, which would be 10. Y to the 7th halves times y to the 1/2. So when you are multiplying where each the same base terms together, now this is where we want to add exponents. So we want to do 7 halves plus 1/2, which would be 8 halves. Well, that's 8 divided by 2, and 8 divided by 2 is simply 4. So that's going to give me a y to the 4th. Again, in order to get that power of 4, well, added these 2 exponents together of the y, and got 8 over 2, and that is actually just equal to a 4 over 5y to the third. And then we want to go ahead and divide, so that's going to give us 2, 10 divided by 5 being the 2. And then when we divide with the exponents, we want to subtract in that case. So when I divide y to the fourth divided by y to the third, in order to divide those two, I want to subtract their exponents, giving me a y to the first power. Okay? So let's go ahead and move on to the next problems. Simplifying radical expressions. All right. So on number 6, we got 50. Okay. So first thing we want to do is we want to get this, find the prime factorization of 50. Okay. So we want to start by finding two numbers that multiply to equal 50. 5 and 10 would work. 25 and 2 would work. Those would be a couple good ways you could start this off, okay? But I'm going to go ahead and I'm going to do it as 2 times 25. And then with the 25, we can then break that up into 5 times 5. And so then we can take this square root of 50 and write it as the square root of 2 times the square root of 5 times the square root of 5. Okay, now then, for every pair that are the same, I can pull 1 out from the square root. So those 2 5s means that I can actually pull 1 5 out of the square root, and then I would only have left the 2. And that would be the simplified answer there. 45. 45 could be written as 9 times 5, and 9 is 3 times 3. So as the prime factorization for 45 then would be 3 times 3 times 5. There's a pair of 3s, so that means that we can pull the 3 out, and the 5 that did not pair up would stay on the inside. Okay? And then 85, let's see, of course, 13, what is it? 17 times 5 is 85. Let's see, is that right? Let's see, 18, 20 times 5, 19, 18, 17, yes. And 17 and 5 are prime numbers. So they cannot be broken up any further, and there's not going to be a pair that would match up in this case. So therefore, we would say that this is already simplified. There's nothing that we can do to simplify that. Okay, so that's just going to stay as the square root of 85. Again, why? Because the prime factorization of 85 is just 17 times 5, and so you don't have anything that would pair up that you could pull out of the square root, as we did with the 3s on the previous problem and the 5s on the problem before that. Okay? All right, so let's keep on moving here. Okay, so geometric sequences now. Let's clear this out here. All right. Let's see, for each problem below, determine if the sequence is geometric. If it is, identify the common ratio R. So if it is geometric, then I should be able to take a pair of consecutive terms and divide one of those terms by the previous term. And if it is going to be geometric, then I have to get a constant ratio, a common or constant ratio. So I need to check and see, is negative 109 divided by negative 9 equal to negative 209 divided by negative 109. Okay. And then is that going to be equal to negative 309 divided by negative 209? And those fractions are actually not equal to each other. If you take a calculator and you divide 109 by or negative 109 divided by negative 9, you get 12.11. So that first fraction here is equal to about 12.11. Okay, if I take the negative 209 and I divide that by the negative 109, that comes out to be about 1.9. So that is not really even close to being the same. So these things are not equal. So this is not geometric because it does not have that common ratio for successive terms. Okay. Now looking at 10, I would want to see there 18. Is that 18 divided by 28 equal to the 8 divided by 18? And is that then going to be equal to negative 2 divided by 8. Okay. And so, you would see here again that you're not going to get that constant ratio. 18 divided by 28 is about 0.64, and 8 divided by 18 is about 0.44. So again, we're not looking at, equal, constant, or the ratios of consecutive terms are not constant. So therefore, I don't have a common ratio. And if there is no common ratio, then we do not have something that is geometric. So once again, this is not going to be geometric on that one. Moving to problem number 11. Is 1 over 0.5, is that equal to 2 over 1? And is that equal to 4 over 2? And in this case, you are going to find that each one of these ratios is equal to 2 in its most reduced form. And therefore, this is geometric. And the common ratio is the 2. Okay. And then on number 12, you would also see that that is also going to be geometric. And the common ratio there, well, if I take negative 8 and I divide it by negative 2, I would get a positive 4. And so the common ratio on number 12 would be a positive 4. Again, if you take consecutive terms and divide one of those terms by the previous term, each time you do that, you would get 4, and therefore that is going to mean that it is geometric. Okay. Let's see what's next here. Okay. All right, so for 13 and 14, the rule is given for each geometric sequence. Use the rule to find the first 3 terms. Okay, so I want to know what f of n is equal to when n is equal to 1. In other words, I want to find out what f of 1 is equal to. I want to find out what f of 2 is equal to. And I want to find out what f of 3 is equal to. And that's really how I would do this for both 13 and 14. So in other words, I plug in a 1 for n, and I do the simplifying to see what that would come out to. For f of 1, for problem 13, we would have 1/9 times 3 to the 1 minus 1. Okay. Now then, 3 to the, 1 minus 1 is 0, so 3 to the 0 is 1, and 1/9 times 1 is 1/9. So the first term in this sequence is 1/9. The second term, now we're going to plug in a 2 for the value of n. 3 minus 1 is 1, and 3 to the 1 power is 3, and 3 times 1/9 is 1/3. Okay, and then for the third value in this sequence, we would now want n to be equal to a value of 3. So that'd be 3 to the 3 minus 1. Well, 3 minus 1 is 2. 3 squared is 9, and 9 times 1/9 is 1. And so the first three values for problem 13, the first three values in this sequence are 1/9, 1/3, and 1. Okay? Number 14 is done very similar to that. The only difference is you're going to be plugging the 1, the 2, and the 3 into that function and seeing what those values would come out to equal. All right. And the next set of questions here, it says, the functions below are written as an exponential function. Find f of 4 for each of the functions. Okay, so something that's very important to understand is that when they say something like find f of 4, that means they want to know what y is when x is equal to 4. And remember that f of x, that's just like talking about y. So in other words, in order to find out what f of 4 is, I want to know what 1,000 times 0.2 raised to the 4th power is equal to. So this would be a calculation that I could certainly do on my calculator. So 1,000 times 0.2 raised to the 4th power. And it looks like that's going to be equal to 1.6. Let me just double check that to make sure that I'm using my phone here, and so I want to make sure that I have inputted that correctly. Yes, it does look like it's 1.6. Just verify that on your calculator. Okay. And then on number 16, the 3/4 really should have had a parentheses around it. So we would want to do 2 times 3/4 raised to the 4th power. Again, y to the 4th power because I'm trying to calculate what the value of f of 4 is. So that's going to be 3/4 to the 4th power. So let's see here. 2 times 3/4, 3 divided by 4, raised to the 4th power. I'm going to about a 0.633. Now then, I don't have a calculator at home like you do, so you can change that to a fraction and see what that value would be as a fraction. Okay. Again, I'm just going to double check here and see if that's the same answer I would get if I so approximately 0.633. Again, that answer is rounded off on your calculator. You would be able to get that answer as a fraction by going to math, enter. Okay, and next, I want to, for 1718, write an explicit rule for each of the following geometric sequences. Okay, so I need to know two numbers in order to write an explicit rule for a geometric sequence. Okay, so we would generally use a sub n, but remember that's just like your y. That's the y way it'd be written here for a sequence. Is equal to a times r to the n minus 1. All right. Now then, the two values that we need to know is we need to know what is the value of a, which is the first term in the sequence, first term. And we need to know the common or constant ratio. Okay. So common or constant ratio or multiplier, whatever you want to call it there. Okay. Now then, to find A, I just need to know what the first value in the sequence is. That's a 4 for the problem number 17. That's simple. And then if I take consecutive terms and I divide them, 12 divided by 4, that would be 3. Well, 36 divided by 12, that's 3. 108 divided by 36 is also 3. And 324 divided by 3, by 108 is also 3. So that is telling me that my common ratio here is going to be 3. And then raise that to the n minus 1. Okay. And then for 18, we would start out at negative 12. And, well, let's see. What do we get when we divide consecutive terms? 6 divided by negative 12 is negative 1/2. 1.5 divided by negative 3 is, once again, going to be negative 1/2. So our constant ratio is negative 1/2. You can see that this is a problem where we get a negative value of r, which we haven't seen up to this point. Okay, but it doesn't change how we do the problem in any way. But you can see that value can be negative. All right, and then for the next problems, we want to write a function for each of the following exponential functions. All right, in order to write an exponential function, I need to know 2 values. Okay, these will be written in the form of a times b to the x. In this case, a is going to be the initial value, and that is the value of y when x is 0. Okay, big difference between a exponential function and a geometric sequence is that what that value of a represents. Now then, b represents the same thing. It is the common or constant ratio multiplier value. Okay, so common ratio, again, you can call it a multiplier. But it is what you would have to multiply one value in the table to get the next value in the table. You can find out what that value is simply, again, by taking a value in this sequence or in the table, in this case, a y value, and dividing it by the previous y value. So I could go 6 divided by 9 or 4 divided by 6. Or 8/3 divided by 4. I could take any of these terms, divide one of the terms by the previous term. It's always got to be that way. It's got to be the previous term. And I can come up with that constant ratio. And that, for this problem, it's going to be a 2/3. Rounded, you always want to reduce to lowest term. So that's going to be the value of b. And we can see that we're told in the table, we can see in the table what the value of y is when x is 0. So that makes it actually quite easy to write this function. It's going to be f of x equals the value of a, which is going to be the 9, times the 2/3 to the x. Okay, and then on problem 20, first thing I'm going to do here is I'm going to find the constant ratio. So I'm going to take the 1/5 value and divide it by the previous value of 1/25. Be careful how you put that in the calculator. Well, division by 1/25 is actually the same as multiplication by 5. So again, actually this would reduce down to a 1/5. Okay. And so that would be, in fact, the constant ratio here is it would be let's see, so 25, so it'd be actually 5. I'm sorry, I did that wrong. That is actually not 1/5. That ratio is actually just a 5. Okay. And let's see, 1 divided by 1/5 would be 5, and 5 divided by 1 would also be 5. So that's going to be, again, the value of a. That's the common ratio value. And then we've got that value of y when x is 0 of 1 over 25. So now that I can say that this function rule for this situation is going to be 1 over 25 times the 5 to the x power. Okay? All right. Okay, so that looks like that's it. All right, so just make sure that you can do each one of these types of problems. Make sure that you're prepared. Do your studying. Make sure that you turn in 12.2 and 12.3 this week. Again, Wednesday morning and or Thursday after school, there will be a tutorial session to go over Test 9. That will be very important. That many of you guys can make it come to that to help improve your grade. Anyway. Good luck, and we will see you on Wednesday or Thursday.